Today we speak about subsystems. Although in the past webinars of HyDraw CAD, I have been sometimes using a subsystem. Today we concentrate about how to create and explaining what the subsystem is. I start from the Library Manager. When you open Library Manager, you find the standard components, accessories, external ports, and subsystems. In a standard setup of HyDraw CAD library, you don't find any subsystem because basically subsystems are up to user. User will build the subsystem that they need and they can save in the library. So shortly, we are going to see how to add the subsystem to our library. But first, let us understand a bit what subsystems are in terms of data structure. So on the right, let me take a pen. We have subsystem types, and by default you will find a set of subsystem in the standard setup: manifold assembly, power unit, pump motor assembly, sectional valve assembly, or valve stack assembly. You can create new subsystem types by clicking new or by click save as, starting from another subsystem type. What we have already preset in the library makes sense, but if you need to define other subsystem types, feel free to create with the Library Manager. Basically, a subsystem is like a component with a set of attributes that we see here, a set of display formats that can be customized like we can do with the components. And if you don't remember how to create display formats, you can look at the last webinar we made about library management. A subsystem may have design properties, but basically when I need subsystem is mainly to store a part of diagrams that I frequently use, or store items where I need to have a model codes, model family. Normally, I don't have that large need like I have for components to search subsystem by design properties or manage display formats for them. Although technically it is possible in the Library Manager itself. In terms of structure of subsystems, they are arranged in different folders in the library. Now you see one of the library I normally use. I don't have many subsystems stored. Basically, you can build the new folders directly in the Library Manager, or you can work directly within HyDraw CAD. So let's switch to HyDraw CAD now, and let's start working a bit with the subsystem. So I have a very small application, a very small filtration manifold, and let me just renumber items starting from 1. And let's say that this is a subsystem that I frequently, this is a manifold that I want to use in different applications. So basically that means I want to store this diagram into my HyDraw CAD library under the subsystems. So in order to save symbols with HyDraw CAD 2020, we need to go to the symbol menu that we have here. And if you remember, when I was adding symbols for components, I was using the components. Now to add subsystem, we use the manage subsystem icon. Manage subsystem icon works exactly the same way as the components, manage components. It will show the current folder structure. You can create new folders. Let me create a new folder called the webinar series. You can create subfolders with a right click, add new, manifold, assemblies. And when you click in a folder, now my folder is empty. I can add a new master subsystem. When you click add a new master subsystem, HyDraw CAD is asking you the subsystem type. You could use none if this is not important for, but in this case, if it is not important for your application, but in this case, I want to use a manifold assembly component type. And we have now 3 options. Select all, I never use it. Basically, it will automatically select all the drawing entities you have in the drawing. I prefer always to do my selection of the entities I want in the subsystem. Although in this case, there is only this manifold, so it will make sense also to use a select all. Specify insertion point is important because when we store, and I recommend this setting for any symbol we create in the library, when we store a symbol in the library, it means that we want later to use that symbol. And it's important to specify the insertion point when we place that symbol in the drawing. So that's the same meaning, specify insertion point. If we want to make this subsystem on the fly in this drawing, we keep this option selected, convert to subsystem. We click OK. We select our entity. We specify our insertion point, maybe B port, and HyDraw CAD is now adding to our library a new subsystem that is available here. Let me clean out. In addition, this subsystem is now stored in the drawing. And as you can see, I have a new balloon, hexagon balloon, and this is a complete with a complete block that can move where you want. This block can be connected, so you can use HyDraw connection lines and connect it to other entities. And when you move the subsystem, the connection will not break like with standard HyDraw CAD connections. In addition, when we click Edit, we will see that this new symbol that we have created has a set of attributes that are deriving from the data structure defined in the Library Manager. So we can specify model codes. For instance, that's our manifold. Let's call it webinar web manifold 1. Our model family is web manifold. The manufacturer is Vest, and the description is manifold assembly, and the functions is maybe filtration unit. We can save this to our database. So the interesting aspect here is that now we can find this subsystem not only by going into the corresponding folder. So if we open the symbol menu, we are in the subsystem. Now we have our webinar series folder with the manifold assemblies, and we can find our subsystem. So with a double click, we can place the subsystem in the drawing and keep using, and it will start taking the numbering. But since we gave a part number, a model code to this, we are also able to find the subsystem by model code. So for instance, we can type web manifold and press enter. Now HyDraw CAD is finding in the database this component. With a right click, we can view the subsystem properties. And with a double click, we can place the subsystem directly in the drawing. As you can see now, automatically I have item 5.1 and item 5.2. Because now these two items are not only a group of components, but they are physically, they are called like super components with the children. In terms of part list, when we use subsystems, in terms of part list, we can make a part list of the entire diagram. And in this case, we can exclude child items. Next. And we can insert our part list. So as you can see, the part list in this case is using an item ID 5 with a quantity of 2, and they are two identical manifold assembly with a code web manifold. But we could also make a part list of the single item. And let me change the part list format. And in this case, we have listing the 5.1 is the manifold assembly, and we have the children of item 5. The manifold 5.1, 5.2 is the check valve, 5.3 is the return line, and the 5.4 is a minimast test point. The purpose of a subsystem is basically the possibility to store into our database a group of symbols in order to be able to retrieve them by molecule, because we may want to use them in a structured part list in a way of managing assemblies and children. If we go to the library manager, again, we go to the subsystems, and well, let me, in this case, I need to restart the library manager because I created a new folder in the subsystems tree. I can see the webinar series, manifold assemblies. I will see my component, and I can also go to my manifold view, and I will be able to see my entities, my model data. Another usage of for the subsystem is like frequently used application, circuits you wanted to start with. So in this case, it means you are not going to use this as a complete symbol, as a group of symbol, but you want to use as loose items to maybe start to make a new diagram. So in this case, we will use the insertion of the subsystem with exploded, in the exploded mode. So in exploded mode, you place a symbol and the subsystem will be placed as loose items. So it will allow you to quickly modify, because maybe you want to add more items to your geometry, and maybe we need an additional valve on A line. So we move this port on the left, and we can go to the components and maybe search for W6J. And we place this symbol directly on the connection line. And we go to the tank line and insert a new tank port, maybe here, a new A port, maybe let's call it B1 here, and we can make some connections. And our tank line. So in this case, I started from a subsystem. I placed it in my exploded subsystem mode, and then I was able to edit very quickly. This will give a lot of possibility to HyDraw CAD users. One suggestion I have is basically store all the standard for those making industrial manifolds. Save all the standard stack modules that you frequently use. And let me make a new one. So let's say that I need a pressure reducing with meter out flow control with a dual PO check and directional control valve. I can use the stack command to make my stack up. And now I want to save this sandwich module to my subsystem library. Again, symbols, subsystems, and I go to the folder where I have my stack assemblies, add a new. In this case, the need to convert the subsystem is not there. We want always to specify an insertion point because it is handy. And the component type is not relevant because we are not needing this as a group of one molecule. We want really to be able to quickly place 4 components that all together. So we keep the component type none. We click OK, select, and define the insertion point. If you need to edit a subsystem, like in my case, I saw some imperfections on this this diagram, we can select and edit master subsystem. I saw that the connection line was not perfectly done. Also, you can change the position of the default balloon, and maybe we want the balloon of the subsystem position there. And maybe this items is not part of our part list. So we edit we can switch it off of the part list. When we are done with the changes, we just go back to the symbol menu and click Save Changes. So this is going to change the definition of our subsystem in the library. It will update the image of the subsystem, and next time we will be able to use it very quickly. Let me close this diagram. Another interesting characteristic of the subsystem is that when we save a subsystem, it will save the status of the symbol in the drawing. So it can also have symbols that are not in our HyDraw CAD standard library. I'll make you an example. Sometimes people want for, let me make an example here. I go to the directional control valves. I take a 4WE. No, let me go directly to the symbol search. I want a directional control valve, stackable symbol, solenoid controlled pilot operated, and I want a big one with maybe external pilot, external drain, double solenoid, spring centered. So sometimes people wanted to represent this kind of valves not with the simplified symbol like we have now, but with a complete symbol showing the primary stage and also the secondary stage, because maybe they need also to have an intermediate stack element in between. So an advantage of subsystem is that we can save basically a status of a symbol that is not available in the library. I show an example I made with my other library that I have. And I go to my subsystem folders, and I go to my stack modules and G16s, and I take these symbols, which I want also to explode. So as you can see, this is an example of standard symbols taken from HyDraw CAD. Well, basically this one has been slightly modified from the standard ones. I changed the colors because I wanted also to look and feel like a standard connection lines. And this symbol is still connected to my standard 4W6J6X. So in this case, I am representing this directional control valve with a closed center with 3 sandwich modules, and this allows me maybe to show the standard valve with the primary stage and the pilot stage, or maybe show in intermediate stack elements that we may need to control the dynamic of this component. If you need, for those that do not know, if you need to modify a symbol in a drawing, you can select it, right click, and do block editor. And in this case, any change that you apply to this symbol, so maybe in this case, I want to represent colors like the HyDraw connection lines. I will use the isolin drain for the drain line. I will use my isolin control line. This is my pressure line, isolin pressure. And this is my isolin reservoir. And those are isolin working line, A and B. This command that I have on top is the layer management. It's normally under the drafting menu command, and it is here. And I add it to my quick access toolbar just by right clicking and add to quick access toolbar. Any command that you frequently need, you can add to you can just mouse over, right click, and add to quick access toolbar. It is handy to have commands in the quick access toolbar because they are visible in any menu you have. So in this case, I have made a change to my symbol. I can close and save changes. And now the changes are applicable only to this symbol in this drawing, not in the library. So if I save this symbol to my subsystem, now it will store this status of the symbol like I see now with all the colors, without touching the symbols that we have in the library. I forgot to say that if you have any question, just feel free to post the questions, and I will be happy to address any queries. So just to recap a bit, and then I will play a bit more with HyDraw CAD. The subsystems are arranged into several folders. In each folder, we find a lot of subsystem, and this is an example of a different library that I normally use, where I have stored more, in this case, manifolds. When you find the by symbol, the subsystem, you can just double click and place the symbol in the drawing. If you have selected the exploded subsystem command, then the symbol will be placed loose in the drawing space, so you will be able to edit anything that you want. You can delete entities, and you can apply any change with the HyDraw command. On the other hand, if you insert the subsystem without explode subsystem command, you can place it, and the subsystem will be placed in one instance, like a block in the drawing. The interface between the subsystem and the other elements is always a symbol ports. So in this case, are connection lines, are external ports, and we can connect any element of symbols with the subsystems. The connection will stay glued. The balloon in my case is an hexagon, and the balloon type is controlled in the HyDraw options. HyDraw options, balloon, and here we find the balloon style defined for the subsystem. Let me take a pen. Here it is. And since we are here, we can see that we have the balloon for the components, for the accessories, and for the hose, flexible connections. Any change that you apply here will be applicable to this drawing only, and not to all the new drawings, because this setting is stored in a drawing template. When you make a part list of entities with subsystems, you will need to pay attention to this option, include child items. With include child item option, HyDraw CAD will list the subsystem as item 15, and will list all the children with the subsystem ID in front as an assembly ID. If you change the subsystem ID, and so in this case, you just select the symbol and change it, maybe to number 210. When we make our part list, now the new assembly ID will be 210 for all the children. But if you don't want the children, we just get back, exclude the child items, next, and we will see listed only the subsystem. Making good subsystems will help a lot by when you need to create standard diagrams. So in this case, we can see NG10, NG16, and so in this case, we can quickly create maybe a sandwich subplate with 4 positions. If, like in this case, I forgot to uncheck the explode subsystem, you can explode the subsystem in a drawing after you place it. And let me explore it. let me explode. So in this case, you can explode the subsystem after insertion, but then you will need to remove the item. So it's better always to explode at insertion. And in this case, we can make quickly connection lines.